Hi folks, my name's Scott and today I'm getting started back on my CNC Plasma project. It's been almost 4 years since I uploaded my last video, so I'm really excited to finally have enough time to start working on it again. I decided to start working on the Z-axis, XYZ, so Z controls torch height. So it's probably the more complex axis because it needs to hold the torch. It needs to also have some adjustment in it for, I want to have a floating head system to detect material height. So I decided I'm going to focus part 3 on the Z-axis and working on the floating head and getting it started. This is my current Z-axis setup. So the way this works is this will ride on the Y-axis, and then this carriage moves up and down with a lead screw, and it's on linear rails. So it's really should have a lot of precision in the Z-axis here. The main thing I want to change is how far this is going to hang out from the machine. So right now these blocks are really thick, so I want to cut those down. I already drilled and tapped some holes here to hold all these blocks together, so I need to disassemble this, and then I'm probably going to take, I don't know, a ½ inch off the face of this material. That way I get a lot more compact package and hopefully prevent any shaking that might occur at the torch tip, because right now this thing would be hanging out pretty far, because like I said, I have to mount a second plate here, and then I need a third plate so it has some type of way to break the torch loose if you have a collision, and then I also need the floating head mechanism. So I'm going to need another set of these linear bearings out here, so it's going to be 3 or 4 inches of overhang, so I want to trim out as much as I can. So I'm going to take this apart and then we'll take it over to the benchtop milling machine and we'll mill it down. So the one thing you have to be really careful with these roller guides is that if you slide them off, you need to be very gentle with them, because hopefully you can see this, there's hundreds of ball bearings in there, and they have a little thin piece of wire that captures them, and if you're too rough, the wire will move out of place, and then all your ball bearings will fall out, and then these are basically trash. Because the little ball bearings in this size, they're so small that it's nearly impossible to find them. So to do the machining operation on this, I'm going to mark all these pieces with a marker. That way I know which ones go where and how it gets assembled, and then I'm going to take all this apart. That way I don't risk losing any of these. I already lost some of this one when I first got it, before I realized how fragile they were when they're disassembled like this. So I'm just going to mark all this stuff. Just do side 1, side 1, side 1. I'll just call this side 2. And make sure you put your marks somewhere that you're not going to machine away. Alright, so the height of these blocks is not really critical. The only thing that matters is that they are the same. So I'll go put these in the benchtop milling machine, and we'll basically just start hogging off as much material as we can. I can't cut a lot off in a single pass. It'd be nice if I had a fly cutter so I could do the whole surface in one shot, but I do not have a fly cutter, so I'll have to set it up and take multiple passes on my milling machine. So. One thing I'm noticing here is that I think this bit is working its way out, or this end mill. I'm getting a pretty good shoulder here. I've had a hard time with this little benchtop lathe keeping this tight, keeping the tools tight in the collets. So you can kind of see the shoulder here. I think I've gone about as much material off as I want. I just need to do a finish pass to make sure this is all flat. So I'm going to tighten up all the ways on the table. I had them pretty loose so I wouldn't be fighting it while I was hogging that material off. But now that I want a better finish, I'll tighten all this down. I tighten the spindle down. I'll make sure the Z-axis travel is locked down, and I'll just skim this off and try to get a nice surface finish. The final pass. One of the things you want to do is if you're using a Bridgeport or something like that and you want to do Z travel, you always use the knee and lift the knee up. You can use the quill, but you should really only use it for drilling or light duty stuff. When you're doing heavy machining, you want the quill all the way up, and you want your travel to be in your knee, or on this type of machine it will be on this it's still Z-axis, but the whole spindle and motor assembly moves up and down. So that's where I'm doing my travel. I'm not using the quill. The quill's going to be locked out. So just bring this down enough to take a very light cleanup pass on it. I don't want to take any more material than I have to. get this up out of the way. Get in there and take a look at the surface finish. Came out pretty good. So this is one of the reasons why I really like aluminum for projects. It costs more money than steel, obviously, but if it gets you the strength you need, you can machine it so fast. And that's dirt, but you can see I'll kind of just wipe my finger across there. There's nothing sharp there, but that's a pretty smooth finish. The little ridges, all these little like circular ridges are from me hand cranking the machine, but the thing that you want to look for is right here. You can see the ridges going this way and then the ridges going that way, and right where they meet in the middle you can see there's no defined line, which means I got a nice flat smooth surface. If your machine is not set up right and it's not square and plumb and level and your head's tilted or something like that, where these two passes meet in the middle, sometimes you can get a line, and you'll actually, if it's really out of alignment, you'll actually get a difference. You might have like a 3 to 4 thousandths difference in service cut, and if it's really out, you could have a really heavy shoulder. So this tells me the machine is very square and everything was locked down good. I'll get these cleaned out and we can take a closer look. So that's the final surface finish, which I'm really happy with. That's going to do everything I need it to. There's no reason for me to want to try to get it any smoother. If you wanted it to be like a mirror, I could have turned the hand wheel slower and it would have made these lines closer together, effectively making it so you couldn't see them. But the transition line between the two passes, there's nothing there. There's no ridge, there's no gap, or no height difference, so that's perfect. And they're both, since they were in the machine together, they're exactly the same thickness. So there's the final part for today. So like I said, the height wasn't critical on these.